This video will discuss the use of the production model in Excel to determine the best production quantity on each production run. The example is problem 1217 from the textbook. In this example, they have a fixed cost of setting up their production line of $50, and the holding cost per light per year is 10 cents. The model here has a place to insert a holding cost percentage or just a holding cost per unit per year. So I'll put a 0 in the holding cost percentage line because in this case they just stated an amount in dollars and cents that it costs to hold each unit in inventory. They have a demand of 12,000 units per year, and their facility operates for 300 days per year. This means that their demand per day is 12,000 divided by 300. It states that they have the ability to produce this inventory at a rate of 100 units per day, and their unit production cost is $1. These are the assumptions that are provided in the problem. The goal is to determine the best production quantity in order to minimize the total of their holding costs and their setup costs. This is different than the inventory purchasing problem because as soon as we make some inventory, we're going to use some of it to satisfy demand. In fact, what happens is if we look at our daily demand and our production, if we start the production line, we're going to make 100 units per day, but we're immediately going to use 40 of them to satisfy demand. The other 60 units will go into inventory. So the percentage of production that's immediately used to satisfy demand is 40 divided by 100, 40%. The amount, the percentage of production that's added to inventory is 1 minus 40%, or 60%. The total unit holding cost also is calculated here as the dollar and cents amount for unit holding cost per unit per year plus the holding cost percentage times the unit production cost. Obviously in this problem there are no holding costs that are stated as a percentage of costs. Nevertheless, we can enter the formula like this so that it's flexible and we can solve other problems. The production quantity is going to be the decision variable in this problem. This will be the changing cell in solver. For now, we just need a starting value. We'll use 50. I'm going to highlight this cell in yellow just to remind me that when I go to solver, this is what we want to select as the changing cell. The maximum inventory in this problem is not going to be equal to the production quantity as it is in the purchasing problem. This is because inventory is only going to get to 60% of the production quantity because we only add 60% of our production to inventory. So for maximum inventory, we'll multiply Q times 1 minus D over P, which we've already calculated. Keep in mind that the 50 may not be the optimal production quantity, it's just a placeholder. The production runs per year would be the annual demand divided by the production quantity that's eventually selected. The length of each production run would simply be the production quantity the total produced in that run, divided by the production per day. So this quantity is calculated in days. The cycle time would be the production quantity divided by the daily demand. We're going to minimize the total of the fixed setup cost and the holding cost. The fixed setup cost is equal to the number of production runs per year times the setup cost. The holding cost is the maximum inventory divided by 2 times the unit holding cost. Keeping in mind that the maximum inventory is not equal to Q, it's equal to Q times 1 minus D over P. The sum of these two costs is the objective in Solver, so I'm going to highlight it in a different color. We're ready to set up the Solver model. The objective is going to be the total annual cost, and we want to minimize this quantity. The changing cell will be the production quantity of 50, and we don't need any constraints specifically. There are none specified in this problem. So we click Solve, and we find that the production quantity is 4,472 in each production run. In looking at the solution, what this means is that our maximum inventory will be 2683, and we're going to have an average of 2.7 production runs per year. So we only start production 2 to 3 times a year. When we start production, it runs for 44.72 days, and the cycle time, or the time in between the start of the production runs, is 111.8 days. This means that the percentage of time that production is running is 44.72 divided by the cycle time, or about 40%. Additionally, in this problem, if we want, we can add in the annual purchase cost of the inventory, which is annual demand times production cost, and perhaps we can name that production cost. And this would give us the total picture about what it costs to both produce and